Hi, in this video, we're going to start our conversation on stateless address auto configuration. And there's a lot happening with SLAAC. So let's begin with the router advertisement. Okay, so a router advertisement, which informs endpoints how to obtain their IPv6 addressing automatically. Excuse me for that cough. Depending on the flags, there are three methods. Oh, okay, sorry about that. Just got a little drink of water there. So let me go ahead and continue with this. But there's three methods, and there's three flags that determine what method to be used. So, whoops, I'm going too fast here. So first of all, let's talk about the A flag, or the address auto configuration flag. When this flag is set to 1, this tells the end device to use SLAAC to create its global unicast address. There's also the other configuration flag. When set to 1, this flag tells the host that there's other addressing information available from a stateless DHCPv6 server. These two flags can be used together. The third flag is the manage address configuration flag. This is used to tell the host, you should use DHCPv6, stateful DHCPv6, similar to IPv4, for receiving your addressing information. If the M flag is set to 1 and the O flag is set to 1, the O flag will be ignored. Now the A flag, SLAAC, it is possible, as we will see, that a host may use both SLAAC and stateful DHCPv6 to obtain two addresses if the host desires to do so. So it's best, if you want stateful DHCPv6 only, to turn the A flag off. So method 1, the A flag is set on, the O and M flags are off. Method 2, the A flag and O flag are both set to on. Shows the defaults for each flag at the top there. Stateful DHCPv6, the O flag is ignored, the M flag is on, and you really should set the you should set the A flag to off. So we can see that by default, the A flag is on. That should be off for stateful. By default, the O flag is off, and that really only needs to be on when you want SLAAC and stateless DHCPv6. And the M flag is on when you want to use stateful DHCPv6. Okay, so showing how this works, SLAAC. We'll be talking about stateless and stateful DHCPv6 in later videos. But so we can see the router advertisement message sent to all IPv6 devices from the router's link local address, indicates the prefix to be used, and the A flag is set to 1. So the host will receive this information, sees the A flag set to 1, and create a global unicast address using the prefix right here, the prefix in the router advertisement, and create its own interface ID. Okay, the interface ID can use either EUI64 or a random 64-bit value. We've talked about those already, but we will be talking about them again. So by looking at the router advertisement, we can see, or after the looking at, I should say, the syscall router, we have IPv6 unicast routing. This command is required for the router to send the router advertisement. To show IPv6 interface, we can see that there is the router advertisement is being sent. First of all, the router is a member of the FF02:2. That's the all IPv6 routers multicast group. So it is going to send out router advertisements out any of its LAN interfaces. Okay, the MTU is 1500 bytes, informs the host the maximum transmission unit of the link. Okay, so looking at other information in this command here, we see that the router advertisement is sent every 200 seconds. This is default. Okay. The router advertisement will live for 1800 seconds. This is the router lifetime information sent in the RA message. This informs the host in seconds that this router can be used or should be used as the default gateway. So remember that the router forwards its router advertisement from its link local address. And this is what the host will use as its default gateway. So this informs the host that, hey, use this this is good for 1800 seconds. Now I'm going to send a router advertisement every 200 seconds. So I have several chances to make sure that you get this RA message and this gets refreshed. It's a nice little way that if the router goes down, that's a way to tell devices, hey, I'm no longer your default gateway, or if this interface goes down. Okay. If this was a 0, this would tell the router, don't use me as a default gateway. And this is an option that you can set. Okay. Okay, this only applies, by the way, only to the router's function as a default gateway, not to other information in the RA message, like the prefix. Okay. ND advertised default router. So down here, so ND advertised default router preference is medium. This is the default for router preferences. You might have multiple routers on the same link, on the same network. And you can choose to have the router preference either a high, medium, or low, depending on which router you want devices to use as their default gateway. Typically, when you have multiple routers, multiple default gateways, it's best to use a first hop redundancy protocol like VRRP or HSRP or GLBP or one of those acronyms like that. So as I mentioned, the DRP, the default router preference, can be high, medium, or low. All right. So every device actually does maintain a default router list because a device can have multiple default gateways in IPv6. Okay. And when it receives the router advertisement, it will add the link local address, the source address of the router advertisement. It will add it to that list. Okay. And remember the router lifetime, so that will be 1800 seconds by default. And be refreshed every 200 seconds. Yeah. All right. There's also an invalidation timer, which is a way to actually delete the router advertisement. Talk about that a little later. Because the A flag is set to 1, this down here we can see host use stateless autoconfig for addresses. Again, that's because the A flag has been set to 1. The O and M flags are set to 0. We'll see the state of that later when the M and O flags are set to 1, how that changes the output here. But the show IPv6 interface command actually shows you some nice information, not just about the IPv6 addressing information, like its global unicast address, what subnets it's on, its link local address, what multicast groups it belongs to, including its solicited node multicast addresses, but also a lot of good information about the router advertisement message. So the router advertisement message, okay, We can see here it's being sent out R1, and here we're doing a debug IPv6 ND. This is a nice command to see. You can actually see the summary of the router advertisement message that's going out. So we can see that here, sending RA. Okay, so it's sending it out on the gigabit 00. This is the source address here. Here's that router lifetime. Okay, and it's sending it to all IPv6 devices. Here's the MTU that's set, and we'll look at some of this other information here next. Okay, so I already mentioned there's the egress interface, and there's the source IPv6 address. That's the address that hosts the end devices will use as their default gateway. Okay, I mentioned sending RA, there's the router lifetime. So the amount of time that end devices can use this router as a default gateway, 1800 seconds or 30 minutes. Okay, it's being sent to FF02 :1. There's really not a colon there in the address, that's just for the bulleting here. But anyway, this is being sent to all IPv6 devices. Okay, and again, the 1500 is the MTU for the link. So quite a bit of information here for end devices. Here's the prefix. Okay, so this is the prefix that with the A flag set to 1. So let's talk about this here in a moment. But with the A flag set to 1, this is the prefix devices can use to create their own global unicast address. Okay. LA. Okay, so that's actually two things here. An L flag, on link flag, we're going to talk about this in more detail coming up. And the A flag, there's our address auto configuration flag. So by default, both of these are set to 1. When the on link flag indicate is a 1, okay, when the L flag, known as the on link flag, is a 1, that's saying that this prefix, that an end device knows that, hey, this is the network I belong to. We're going to talk more about that in a moment. Okay, when the A flag is set to 1, that tells devices, hey, you can use this prefix to create your own global unicast address. Okay, so we're going to talk more about that in a moment. We have a couple big numbers there. These are actually the valid lifetime and preferred lifetime in seconds. Okay, we'll be talking more about that in a moment. All right, you can see that there's quite a bit to IPv6, and people thought it was just longer addresses. Don't get intimidated by these large numbers here, but anyway, we're going to talk about valid lifetime and preferred lifetime in an upcoming video in SLAAC in this chapter. Okay, so the end result is this, and all of this is going to be explained soon. But the end result is the device is going to create its own IPv6 address using SLAAC. Wait a minute, Rick, I see a lot more there. Well, let's see, I see a default gateway. That was the source IPv6 of the router advertisement. But wait a minute, it created 2 addresses. What's this, an IPv6 address and a temporary IPv6 address? We'll talk about that more in a moment. But notice that they both have the prefix that was advertised. Okay, and it looks like that they created that this Windows PC created the interface ID randomly, not using EUI64, because I don't see FFFE in the middle of these here in either one. Okay, so 2 global unicast addresses. There is no private addresses, so don't get that confused here. They're both public addresses. But the first one is we call it a public address, but the other one is a temporary address, but they're both globally routable. Okay, we'll talk more about why there's a temporary IPv6 address. We're going to talk more about that in this series of videos in this chapter. But it's one of the enhancements that's part of IPv6, giving you more privacy. So we'll talk more about that. It's also known as the privacy extension. We have the random bits, known as privacy extension, and a temporary IPv6 address. We'll be talking a lot more about that. All right. So that's just the beginning to looking a little bit at the router advertisement message. A lot more to come.